or demonstrated in question number 2 is the addition property of equality. And the reason is I am adding equally to both sides of this equation. When I add equally to both sides, we call that the addition property of equality. Number 4 is the transitive property. To demonstrate the transitive property, I'm going to rewrite this. Over on the right, I have GH is equal to MN, and MN is equal to OP. So if GH is equal to MN, and MN is equal to OP, then we can make the conclusion that GH is also equal to OP. So when I see it like this, I think of a train. First car is connected to the second car. The second car is connected to the third car. So the first car is connected to the third. Just a clever way to think about the transitive property. It's like a train. Number 6 is the reflexive property. And again, another way to remember about the reflexive property is it looks like this is a reflection. Number 8 is asking you to write a segment statement using the transitive property, so very much like number 4. I might write something that says, if AB is congruent to, and I'm going to use my segment AB is congruent to segment BC, and segment BC is congruent to segment CD, then segment AB is congruent to segment CD. All right, in number 10, I need to write each conditional statement by separating the hypothesis with the conclusion. The hypothesis is the part of the statement that begins with the word if. Conclusion is the portion that is then, the portion that begins with then. So, number 10, if RT is congruent to segment AB, then segment RT is congruent to segment LM. So this is the hypothesis. This is the conclusion. In number 12, we're going to complete this proof. And in this proof, they want me to prove that vertical angles are congruent. And the vertical angles that they want me to prove congruent are angle 1 and angle 2. So at the end, I'm going to prove that not 1 and 2, the measure of angle 1 is congruent or is equal to the measure of angle 3. And those two are vertical angles. So I'm going to use all the rules up here to prove that 1 and 3 are congruent. So in the first step, we see that angle 1 and 2 are a linear pair, and that's given in the drawing. Angle 1 and angle 2 are a linear pair. They're supplementary, which means that they add up to 180 degrees. And so logically, we can also say that angle 2 and angle 3 are also a linear pair. So if angle 2 and 3 are a linear pair, then we can now say that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So that again is by the definition of supplementary angles, which we'll skip here in number 2. Two angles that add up to 180 degrees. And likewise, angle 1 and angle 2, since they are a linear pair, they also equal 180 degrees for the same reason, by definition of supplementary angles. Now we have two statements that are equal to 180 degrees. So using the substitution property, I can now write the following. Measure of angle 2 plus the measure of angle 3 is equal to measure of angle 1 plus the measure of angle 2. And therefore, by the subtraction property of equality, if I subtract the measure of angle 2 from the left side, and I subtract the measure of angle 2 from the right side, I'm left with the measure of angle 3 equaling the measure of angle 1. So because we subtracted equally from both sides, we use the subtraction property of equality. Number 16. All right, I'm looking for an equation that will help me to find x. Here's what I notice. Notice that these three angles together equal 180 degrees. This angle here is 90 degrees. Therefore, these two angles together have to equal 90 degrees. So the equation that I'm going to use is that 4x plus 4b6 is equal to 90 degrees. Number 18, both of these angles are supplementary angles. So together their sum is 180 degrees. So therefore, I can say that 3x plus 6, this first angle right here, together with 117 degrees, this angle right here, altogether is equal to 180 degrees. Now to do problem number 20, I'm going to borrow the answer from number 18. In number 18, we solved for x. We found that these two angles together were 180 degrees. So when we solve for x, we found that x was equal to 11. Which means that this angle down here in this corner is 11 degrees. Now, what I know about the angles in a triangle is the three angles together add to 180 degrees in a triangle. The sum of the angles is 180 degrees. So I could say that y degrees plus 11 degrees plus 117 degrees together